Hi, this is David Ojeda with Fritz-Pak Corporation, and today we're going to be answering your most frequently asked questions about, air products. So if you've got concerns about air in your concrete, you're going to want to watch this video. And if you have any questions of your own, feel free to leave them in the comments, and if we use your question in a future video, we'll send you some awesome Fritz-Pak related swag. Okay, so let's get to it. So how do I know if I need Air Plus or Super Air Plus? I guess this question is really meant for maybe like a contractor or somebody who's making concrete themselves. And sometimes it's like, well, do I even need any kind of air entrainer or any kind of air in my concrete at all? And really the only way to answer that is if you are in an area that has freeze-thaw cycles. So pretty much anybody in North America is going to need some kind of air entrainment in their concrete. Uh-oh, I got a tricky one. I've been using dish detergent in my concrete for years. Why should I switch to an air entrainer like Air Plus? Oh boy, okay, so don't use dish detergent in your concrete. Please don't. So regular dish detergent, soaps, shampoos, things like that, they rely on sodium lauryl sulfate. So you can, check your ingredients and you'll find sodium lauryl sulfate everywhere. The problem with that is that it is not mineral salt tolerant, okay? So concrete or cement in general is a mineral rich environment. So you're gonna be dealing with a lot of mineral salts. So regular, over-the-counter soaps and shampoos and things like that, yes, they are surfactants. Yes, they will foam. Will they perform well in a mineral salt environment like concrete? Not really. They're going to be very unpredictable and unreliable. So the chemistries that we typically use for air entraining in concrete are going to be things like Vinsol resin or rosin soaps or olefin sulfonates and things like that. Those are chemistries that are mineral salt tolerant. So that's why we have to use special chemicals for concrete and not just your run-of-the-mill, dish soap. Okay, last question. I can never seem to get the results I need when using an air detrainer. What am I doing wrong? Okay, so this is more of like an air minus type problem or type question. Air in concrete is it's very tricky, right? I mean, there's a lot of factors that can affect how air is entrained into concrete. It can be related to, obviously, how much air entrainer you put into it, the superplasticizer, the cement content, the types of cement, supplementary cementitious materials. So, the fly ash can have low carbon content or high carbon content. All of these things are going to play a factor in how much air is in your concrete mix. The question becomes, why do you have high air in the first place? And in situations where you have naturally high entrained air, it's very easy to bring that air down with a product like Air Minus. So, if we know the air is being caused by, let's say, the fly ash or something like that, yeah, using Air Minus is going to be very predictable and very reliable. When we have too much air entrainer in the mix, basically this is concrete that was made with an air entrainer, at the plant, and it's getting to the job at like 8 or 9% air, and the spec's only for like 5 to 7. In those situations, you have to use additional amounts of air detrainer to counteract the entrainer that's already in there, because air entrainers by their nature are stronger than air detrainers. So number one is you need to be using the right amount of Air Minus for the situation. And the other thing is that we're introducing the Air Minus via mixing, right? Anytime you're adding any kind of product, on the job site, you have to mix it into the concrete. If you already have a high air content in this concrete mix, we know it's already promoting foaming. Like the mix is going to naturally want to foam. So as you're mixing the concrete together, it's going to generate some amount of foam, which is unfortunate because the exact thing we're trying to do is to bring that foam content down. But we don't really have a choice. That's how we have to get the detrainer into the mix. But then we need to give it time to work. So usually what happens is people will rapidly mix any detrainer product in and then immediately test the concrete. And you can't do that because, just through the action of mixing, you've already foamed that concrete up. You should expect a high air entrainment in situations like that. When you're adding a detrainer, you need to give it time to mix in slowly, or even let the mix stop for a little bit to allow the air to escape, because the detrainer is there to, change the surface tension of the water, to allow the bubbles to pop easier and faster. So that's why you have to make sure that you're mixing appropriately, but then you're also giving some slow speed and some no speed time to the mix to allow for the detrainer to actually work. All right, well, thanks for watching our video. I hope that helped educate you on, air entraining issues that you have with your concrete. If you haven't already, make sure that you like and subscribe to our channel for more information on how our products can improve your concrete. And again, don't forget to comment on this video with questions that you have about your own concrete mix. And if we feature you in a future video, we'll send you some awesome swag. So thanks a lot.